Hello, my lovelies! It's Susanne, and today I want to show you how to solve this problem. Inside a circle lies a square whose corners touch the circumference of the circle. If the circle has a radius of r equals 3 centimeters, then the area of the red-colored region is A, B, C, D, or E. We have our circle here, and inside of this circle we have this square, and we have to find the area of this red-colored region here. So I call this area A, and it consists of the area of the whole circle, so I call it a circle, but that would be too much because this would be all this area, but we have to subtract the area of this square here because it's white, so from the area of our circle we subtract the area of the square. That's our plan. So we first have to find the area of the circle. For this, we only need the radius of our circle. We have that. The formula for the area of a circle is pi times the radius squared. So the radius is 3 in our case. We put that in here, and we've already found the first part. Now we have to subtract the area of the square. For this, we need the length of the sides of our square. We don't have that yet, so I call this side x, and since it's a square, the other side is of length x as well. For the area, we have x times x, so x squared. The only thing we have to find is the length of x. Then, if we have that, we can solve it, but we don't have it yet, so let's try to find the length of x. We only know that the radius is of length 3, but the radius is also part of the diagonal through our square here, and the radius is half of the diagonal, so the length of the diagonal would be 3 times 2, so it would be of length 6. Now we've built a triangle here, a right triangle because of the square, and we can use the Pythagorean theorem to find out the length of x. For this, we first have to find the hypotenuse of our triangle. That's the side lying across the right angle, so this green colored side, that's the hypotenuse. And the Pythagorean theorem says then, take one of the legs of your triangle, so x, and square it, plus take the length of the other leg, it's also x, and square this as well. And this equals the hypotenuse squared, so 6 squared. Okay, now we have one equation. We want to solve this for x. On the left side, we have x squared plus x squared, which equals 2x squared. And on the other side, 6 squared, 6 times 6 equals 36. Now to solve for x, we divide both sides by 2 to get rid of this 2 here. This cancels out and only x squared is left. And here we have 36 divided by 2 equals 18. Now, we could solve this for x to find out the length of x, or we could think about what we really needed. So let's go back. We take this with us, x squared equals 18. And we were here trying to find out our area. And in this equation here, we only need x squared. So we could stop here with x squared when we found it and put the 18 in here directly. So our area is, we can simplify this part here, 3 squared, 3 times 3 equals 9, and then I like to switch these two, so write it as 9 pi, and subtract x squared equals 18, so we subtract 18. This is our result, and now we have to figure out if it's A, B, C, D, or E. Here we have 8 and pi. So if we get rid of the parentheses, we would have 8 pi. This doesn't work with our 9 pi, so that's not the solution. Here, 6 times 2 pi is 12 pi, so this also doesn't work. Here we have 9 pi, but the second part, the minus 25, doesn't work with our 18. Here, if we get rid of the parentheses, 9 pi minus 18. So this looks good. This is not the solution. So D is what solves our problem here. I hope you enjoyed it and maybe figure it out by yourself. I wish you a wonderful day and I hope to see you in one of my next videos. Take care.